to the New York Islands, from the redwood forest to the Gulf Stream waters. This land was made for you and me.
I'm Allison Klein Sherman from Tips and Trips with Klein Tours, and we're at the Hagley Museum and Library today. And Cheryl Nathan is with me, and she's going to tell us about the mill area of this wonderful property.
Yes, this is where Eleuther Irénée DuPont established his powder yards in the year 1802, and they were in use until 1921. So it's a long history here. Behind me is the Birkenhead, and this is reminiscent of the way the water wheels operated the machinery that produced the black powder. These wooden water wheels only lasted about 10 years, and so later you'll see how the turbines operated to provide the power for black powder. Safety was extremely important, and you can see the way the buildings are constructed in pairs with very thick side and rear walls. The roof is slanted, the front open, so in the case of an explosion, which there were, the debris would go across the river. In the time that we were here and these yards were open, research to date says 288 explosions, 228 fatalities. That was still a very good record.
Wow.
Safety was really very important.
Yeah, for that time and the length of time, that's really, I think, very impressive.
Yes.
And it's also very impressive how intact these buildings still are. It's really a beautiful area, and the preservation here is wonderful.
Well, one of the other reasons why Mr. DuPont selected this area, the major one being the Brandywine, was that there were quarries here to provide the stone for these buildings. Also, the three ingredients to powder were sulfur, saltpeter, and charcoal. And the property also had black willow trees that they processed for the charcoal and provided a good product for their mixture.
Wow, great. Thank you so much, Cheryl. I really look forward to exploring this area today. Thanks for joining me.
Quite. Come again.
Thank you. Rodney, one of the guides here at Hagley Museum, is going to tell us a little bit about the history of the powder yard and how everything worked here. Rodney, tell us, what is this waterway that we're standing over, and what was its importance to the powder yard?
Okay, this entire area was once a factory. Mr. DuPont, that would be E.I. DuPont, he started a black powder factory here in the early 1800s. He bought 65 acres of land here in 1802, and he bought this part of the property in 1813 to extend his powder factory for the war that came to America. He had to use the river for power, and the way he used the river is this what we're standing on. It's called a mill race. It's a man-made ditch about 8 feet deep. There is a dam about a quarter of a mile upriver moving water into the mill race. The mill race and the dam are level at that point, but as we come downriver, the river drops 17 feet. So when I release water from this mill race, it gives me the hydraulics to power equipment that once was here. These were all mixing mills to mix the ingredients in black powder. Black powder is not a chemical mixture, it's a mechanical mixture. Very simple, just 3 ingredients: saltpeter, charcoal, and sulfur. Put them together, grind them, and you have black powder. Now, these buildings would have been grinding or mixing mills. And I'm going to take you all down to demonstrate how we would use the water to power the equipment that once was here. Just for your note, at one time we used wooden water wheels to power all the equipment here. Between each set of these buildings would have been one wooden water wheel. But because wood rots in water, it caused them much production problems. The DuPonts decided in 1840 to take all out and put in metal turbines. We have a couple on the property that still operate. And for your instance, I want you to know that we have done nothing to change this property. This is a true historic site. This is the way it looked then, with the exception that the buildings were operating. So if you'll come with me, I will demonstrate for you water power.
All right, great. I'm looking forward to it, Rodney.
Okay. When Mr. DuPont established his waterways here, in order to operate it, he had to build what we call a sluice. This is called a sluice. We have a pipe that goes down to the river. It's about 3 feet in diameter. When I release water from that mill race that we spoke about earlier, it's going to move through my sluice and it's going to go straight downhill and operate my turbine. As I mentioned before, this is a historical site. In order to keep the wrong folks from touching things and messing with them, we keep them locked. I have the key. Now, I have to lift the gate. The gate weighs about 300 pounds. In order for me to do that, I'm going to be quiet for a moment and just use my muscles. And you will hear the turbine when it begins to move. This turbine was put here in 1840. It is the original turbine. No, not yet. That's the turbine that you hear starting. Would have been 16 of those here operating at the same time. Think of this like a big on and off switch, like a water faucet. I can control the speed using this. Now, if you'd like, I'll take you down there and show you what the turbine is operating. One of the reasons why Mr. DuPont selected this area in Delaware in the Brandywine Valley, after looking in several states to start his black powder factory, is this stone that you see here. This stone is called blue gneiss, G-N-E-I-S-S. It's a very strong metamorphic stone. It's quarried right here on the property. There's a baseball team in Delaware called the Blue Rocks. These are the Blue Rocks. Another reason why Mr. DuPont selected this area is because the way the land is structured. All of the homes would have been behind us, uphill. He could build his powder yards down here in the event there was an explosion. You'll note as we go around the corner to see the mixing wheels that the roof is very flimsy and there is no front. If we have an explosion here, we wanted to go up and across the river. No one lived on that side of the river. Powder man, which I am today, would never do what we're doing. He would never go behind there while he's mixing the three ingredients, too dangerous. He would stay behind one of those protective walls. These are the mixing wheels. Early on in the progress, Mr. DuPont would mix his three ingredients using a pestle and mortar system, banging the three ingredients. That was not good. It would cause explosions. The other thing that they worried about here was getting a piece of tramp metal in the mix. It would cause a spark. These rolling wheels weigh 8 tons each. And remember, we would have two sets, 16 tons here and 16 tons on the other side, all powered by the Brandywine. And the water is going right back into the river, nice and clean. So we can use it again. In here, they would put about 300 or 400 pounds of the ingredients and begin to roll across it for about 4 or 5 hours. And then it would go to another stage after that. You will also note that everything here is metal on wood, wooden tub metal wheels. We never have metal on metal. We don't want to cause a spark. This is the turbine that's below the water that we use to operate the systems here. Water goes into little openings in this turbine, and we have inside, think of a pinwheel that turns, and it operates shafts that would come off of this turbine. This, by the way, is a horizontal turbine, put here around 1840. A little bit later on, you're going to see a vertical turbine that was put here around 1890, more modern and much more powerful. Now, I'm going to demonstrate for you a little black powder. In order for me to do that, I'm going to use something called an eprovette. It is a French tester. It's used to test the quality of the powder. What differentiated Mr. DuPont's powder from all the other powder makers was his refinement process. After he refined the ingredients, he would test it. If it did not pass the test, he would not send it to market. And the way this operates, I have a cylinder, I put powder in it, I put a fuse, and I close the wheel. The wheel is numbered. But we know from experience that if we can get the wheel to go about there, that's acceptable quality. And by the way, DuPont salesmen will use this as a tool to demonstrate their quality of their product compared to the competitors. So I'm going to demonstrate a little powder for you. For those of you that have never seen black powder and you've spent most of your life wondering what does it look like, well, after today you can cross that off the bucket list. This is black powder. It looks like black powder. DuPont policy is always safety first. So, as long as you folks stay on that side of these rivets, everyone will remain safe. You notice I had powder, a fuse, and a tester, but I did not have fire. I'm going to get fire. That makes me a dangerous man. If all goes well, this is about a 6 or 7 second fuse. We should have a little bang. That is excellent powder. Our wheel went all the way around, as you notice. And I want you to keep in mind, if you saw the smoke that came from the powder, if you think of a Civil War battle, 50,000 soldiers firing a musket at the same time, you had an issue. You could not see, you could not breathe. And it leaves a lot of debris. I have to clean it. If I do not, the same as a musket, it would not operate. Now, the DuPont company in the late 1880s, they went from this powder to smokeless powder. It's a chemical composition. On the next show, I will break down that composition for you.
Pete is going to tell us about the Hercules water turbine that we're here seeing right now. Tell us about how that has affected everything in this industry here.
Okay, hello everybody, my name's Pete. What I'm going to demonstrate here is a Hercules water turbine used here at the Hagley. It was installed in 1890 and it was operational till 1902. In 1902, this machine shop moved downstream and the water turbine basically sat here from 1902, excuse me, until 2011. The water turbine itself sat underwater during that time. In 2011, using some technology, they found the turbine, they unearthed it, restored it. Right now we use it to power the machine shop, and the machine shop is a actual 1870s working facility that was used here at the Hagley. This particular water turbine uses the flow of water and the weight of the water to turn a 43 horsepower turbine. We've scaled it to about 10 horsepower for safety reasons. It's a 1,000 cubic foot vessel, and we're going to rapidly flood it with 66,000 pounds of water, using the water from a mill race here on the Brandywine Creek. So I'm going to give a thumbs up to my partner. He's going to open a sluice gate, and when he does, the water's going to drop 17 feet into this 1,000 cubic foot vessel. So here we go. You'll notice it fills quite rapidly. We control the flow of the water using this throttle crank here. The rock there is a counterweight, that's used to just help us open and close the turbine lid. By doing that, we're able to vary the amount of RPMs, horsepower of the turbine. In a moment, you'll see the gears begin to turn, and through a series of gears and pulleys, they'll begin to operate a pulley and a line shaft inside the machine shop. The pit is right now filled by about a third, almost halfway, and it took less than a minute. Eventually it will fill to the top and overflow, and it will run all day like that. Pure green energy. Again, what's interesting about this turbine is that it's the original equipment. It's one of the pieces of actual functioning equipment here on the site that survived 1922 and the World War II, when a lot of the metal on the site was used and recaptured and melted down and used for the war effort during World War II. So again, what's interesting to note about this is it sat underwater for over 100 years and it's still operational. Hi, we're back in the machine shop. Here at the Hagley in 1870s, a lot of things were happening. As many as 300 people might have been working in here. In this particular facility right here is called a machine shop. This is a repair facility. In here, broken gears, broken tools, line shafts, that type of thing were repaired by machinists. Machinists were usually about 20 to 45 years old. They made anywhere from about 15 cents to 17 cents an hour. They worked 6 days a week, and they worked 10-hour days. And in here, they would have had some helpers, some apprentices that were aged 12 to 16. We saw how the water turbine out there generates 43 horsepower. And what I'm going to do right now is take that same power, it's generated through a series of shafts and pulleys, and I'm going to slide this leather strap over, and when I do, we're going to activate a line shaft that runs along the ceiling. Emanating from the line shaft, as you can see, are a number of leather belts, and feeding from the leather belts are any number of different machine tools in here. In here is where they would have repaired the broken tools, the broken gears. This is typical of a gear in those days that would have been either repaired or start over from scratch. As you can see, holes were drilled in there and bolts were tapped in there, and this would have been a quick fix in a machine shop. However, in some cases, a whole new gear had to be made. And one of the really startling technologies of 1870 was a machine called a Brown and Sharp milling machine, and this could do a lot of things for us. And this particular milling machine used a series of cutting wheels. This cutting wheel has 10 sharp edges, so the actual process here is much more efficient than some of the things that had been used before. So here's where we would have cut the teeth for the gear. All the gears were different. There was not a lot of commonality of parts. So a machinist would have to come over. They would need to know how to set up their machine, and on this milling machine, a machinist would, of course, need, where would one be today without a handheld calculator? Here's a handheld calculator from 1870 to help our machinists set up our milling machine. Since each gear has a total different number of teeth, there's an infinite number of gears that can be made over here. Actually, 253. But to set the machine up right here, this particular machine will not only cut the number of teeth, it oscillates back and forth in a longitudinal direction, it spins, and it knows how many teeth to cut. I'm going to go ahead and just move it over again, and as we can see, it's spinning. It will do a number of things. Like I say, it will spin, it'll go back and forth, it turns. But the machine needs to know when to do all this. So in those days, what they would do is they would take one of these wheels, they would set the machine up to make the particular gear that was being made. Once the machinist had set that up using any number of these discs, the machine would run on its own. And what is interesting to note is that each one of these discs has a series of numbers. It also has a scale here. Once set up, it's running. So this is 1870. The technology in those days was sophisticated to know that this is an analog hard drive. We have there an 1870s computer. Remember, the Civil War had just ended 5 years when this technology was developed. So once plugged in, this analog hard drive would go ahead and that machine could run on its own. Pretty sophisticated stuff. Okay? There's some other neat things in here that I'd like to point out that show really these guys, these machinists, the technology of the time, given what they had to work with, they were very, very, very mechanically sound and quite sophisticated. What we've got right here is what's called a cone drive. If you notice on the top cone is spinning. Wedged in between the bottom cone and the top one is a leather belt. And this is just basically cowhide. And as it is right now, the two cones are not engaged. I'm going to take that lever and use the energy from the power turbine, and I'm going to engage the bottom cone. And when I do that, it's going to activate this drill. Everything we've shown you so far has a fixed pulley, so we can only really change speeds maybe 4 different ways. However, using this technology, I'm going to take these 2 ropes, and I'm able to slide the leather belt to the right or the left. When we move it to the right, listen carefully, and you'll see what's going on here. The drill slows down. We take advantage of the different circumferences of the cone to vary the speed on the drill. Using the ropes right now, I'm going to slide to the left, and as I do so, the drill speeds up. So we're talking right now about 1870, 1875 technology, and this is how you could vary the speed on a drill. So the folks in those days, they might not have had computers, they might not have had certain of the electrical advantages we have today, but basically using river power and a turbine, we're able to vary the speeds on a drill using this cone drive. I'd like to point out just a couple more things as we go along here. One of the questions a lot of people ask me is over here is, why are these belts twisted? Why is one belt twisted and why isn't the other one twisted? Both of those belts activate this lathe. Watch carefully as I go ahead and I'm going to engage the belt that is not twisted. Notice the direction of the lathe. It's spinning right now in a clockwise direction. Well, oftentimes we needed to reverse the direction on that lathe. So to do that quickly, the machinist would just basically stop the lathe and then switch to the twisted belt, and the twisted belt takes the same drive. However, if you notice now, the lathe is going in the other direction. It's now turning in a counterclockwise direction. So again, we're looking at 1860s technology. This is how they got things done. They were very, very innovative people. And remember, this is a manufacturing facility of black powder. Time is money, money is time, downtime is costing you money, so they needed to be efficient. One last piece of equipment I would like to show you is a planer. This is a plein air machine. It's made in Worcester, Massachusetts. We estimate it's about the same time frame, 1868. Remember, this is the Victorian times, the 1800s. The folks that made this equipment were very, very proud of what they made. So from a point of view, please notice that you've got crown molding on this machine. It still has the original green paint. Over on the side here, we've got Roman columns, ornate feet on the machine, a very, very intricate sprocket. And basically all this machine was made to do was take big pieces of metal and turn it into useful smaller pieces. They did not have the advantage of the polarity of an electrical motor, so they had to use other means to reverse direction. And what I'd like to point out is, while it's planing, please watch right here and this belt, and this is how we switch directions here. Notice the belt slid to the left. Now it's going the other direction. And again, the workmanship involved in this, the people that built it took pride. you as a machinist on here would be proud to work with this piece of equipment also. So it's really a unique glimpse into history 150 years ago. Okay, the last thing I'd like to show you is a model. This is a model that was developed in London, England for the Harvard Engineering School for engineering students. And its basic role in life was to show the engineering student how various different gears worked. And as you notice on here, there are many different types. Gears, gears, gears. The thing that I like to point out with this is that this particular model was built here at the Hagley. This was made by actual machinists 30 years ago in this exact same building using some of this exact same equipment. And what's worth noting is that everything was built by hand with loving care with using this equipment. And I point this out that this is the stock metal that this one particular piece was cut from. And again, the role in life of this entire model was to teach engineering students the fundamentals of gears, spur gears, rack and pinion camshafts. Again, 1850s technology.
We'd like to thank the Greater Wilmington Convention and Visitors Bureau and the Hagley Museum and Library for hosting us today. It's been a wonderful day here with my mom, Adele Klein. I'm Allison Klein Sherman.
And I'm Adele Klein, and we thank you for joining us today. And get your groups together. Contact our friendly staff at Klein Transportation. It's wonderful when you actually experience historical sites such as this beautiful area. And we'll be glad to set your whole day up together because motor coaching is so much fun, and we appreciate you as our customer.
From Hagley, the most beautiful mile of the Brandywine, thank you for joining Klein Tours, Trips and Tips.
Hello, I'm Wayne Klein, President and owner of Klein Transportation, along with my wife Adele. We've been providing passenger transportation since 1957 for students going to Daniel Boone School District and charter business since 1979. Allison, our daughter, is actually the representation of the fourth generation of the Klein family.
We invite you to join us to go to many fun travel destinations. Our motto is half the fun is getting there. We are so proud of all of our staff of travel specialists. Whether you contact us by phone or online, we help you choose a Klein tour, a casino trip, or to schedule your transportation by motor coach or school bus.
Let's step on board and choose our next destination.